All right, it's Monday. Right now, I'm flying back with two small children. Hopefully, they're not crying. We get to talk about similar polygons. In case you don't know, similar figures have the same shape, but not necessarily the same size. This symbol right here, the little squiggly that looks like the one you put above the congruent symbol, that's the symbol for is similar to. So these are similar. Notice they have the same shape, but one is bigger than the other. So in similar figures, the corresponding angles are going to be congruent. The sides are going to be proportional. So AB to GH is equal to BC to HI is equal to CD to IJ is equal to AD to GJ. So there's that extended proportion. Notice we can put all four of them. They're all equal to each other. All right, so we're given a little picture here, and they tell us that triangle MNP is similar to triangle SRT. That means that we have some congruent angles. What would they be? Now, you don't even need the picture over here. You know from our triangle congruence things that M and S correspond, N and R correspond because they're the second letters, P and T correspond because they're each the third letter. But you can use the picture if you want, that's fine. And you can answer this question again without a picture because those segments are going to correspond to each other in the similarity statement as well. All right, so I know that since M and S are the first letters, those two angles are going to correspond. They are going to be congruent. Let's look at our picture. Doesn't that look to be true? Sure does. Next would be angle N is congruent to angle R. Again, look at your picture. Sure looks to be that way. And then finally, third letters. Angle P congruent to angle T. Awesome. And then the extended proportion for the ratios of the corresponding sides. So I know I can use this or I can look at my picture. It doesn't matter, whichever you want to do. MN, that's the first two letters, corresponds to SR. And also look at the picture. MN, 1, 2, SR, 1, 2. See, they definitely line up. MN to SR is equal to MP, the first and third letter, to ST, the first and third letter. And then we've got NP, the second and third letter, to RT. Those are all proportional. And what that means is there's some magic number that I can multiply this by, and that for each segment, I can multiply MN by something and it's going to equal SR. That same number, if I multiply it to either of the other two sides, would also equal the bigger triangle. So that's called a scale factor. That is the ratio of the corresponding measurements of the two similar figures. All right. So here's what you're going to be doing. We're going to identify first, are these similar? And if they are, we're going to write a similarity statement and we're going to give the scale factor. So how do we do that? Well, we're going to set up corresponding sides as ratios and see if they all reduce to the same thing, pretty much. That's the easiest way, I think, to do it. So let's look. 6 corresponds to 6. And then just go around the figure. 12 corresponds to 6. And then just keep going. 16 to 24. And then last, 14 to 24. Oh, I made a mistake. Sorry. Let's try that again. I did 16 to 24. It should have been the other way. Left to right. Always keep the same. Left to right. Okay, left to right. Here we go. Try again. 6 to 6. 12 to 6. 24 to 16. And 24 to 14. Awesome. Okay. Then just reduce each of the fractions. Do they come out to the same? 1 Is that equal to 2? Is that equal to this divides by what, 4? No, 8. 3 to halves. And this one divides by 2, 12 to 7. None of those came out to be the same. So they're not similar. They all have to be the same number in order to be similar, and none of them came out to be the same. They're all different from each other. All right, let's look at the next one. Again, I'm going to do the left triangle on top, the right triangle on bottom. Okay, now this one's tricky because the triangles have been flipped around, so you kind of got to look. 12 has the arc marks for 2 and 3, so you got to find the segment over here that has the arc marks of 2 and 3. So there's 2, there's 3, so it corresponds to 15. 8, I'll do that one next. 8 is in between 1 and 2. So over here, 1 and 2 is 10. And then the last one is 16. 16 is between 1 and 3. Between 1 and 3 is 20. All right, let's reduce each of those fractions. This one divides by 3 to give me 4/5. This one divides by 2 to give me 4/5. This one divides by 4 to give me 4/5. All of those are the same, so they are similar. Now, again, with our similarity statements, we need corresponding angles to line up. So I'm going to name that triangle on the left first. Triangle ABC is similar to triangle. Okay, A has 2 marks, B has 2 marks, B has 3 marks, E has 3 marks, C has 1 mark, F has 1 mark. And what's the scale factor? Well, that depends. If I'm going from triangle ABC to triangle DEF, I would multiply by 5/4. So from ABC to triangle DEF, the scale factor is 5/4. How'd I get that? I flipped that around. It has to get bigger, so it's got to be multiplied by more than 1. If I'm going from triangle DEF to triangle ABC, the scale factor is 4/5. Take these numbers, multiply it by 4/5, it'll come out to be these. Or if you take these numbers and multiply them by 5/4, it'll come out to be those. So that's how you find the scale factor. Not that difficult. All right, let's see what's on the back. A couple more. Why don't you try those on your own and see if you can get the correct solutions. So pause the video. I'm going to pop up the answers in just a second. Okay, so I'm going to do left to right. Notice the short side 10 corresponds to the short side 15. We want to know, is that equal to 15 to 20? So let's reduce those. That reduces by 5 to 2/3. Divide by 5, and this one is 3/4. Are those equal? No, those are not the same numbers. Not similar. On this one, I'm looking, and I mean, this one's pretty obvious. Each of the two, like, bottom of the home plate looking things goes to 12, and the other 3 go to 18. Well, obviously, what's this? It's similar, because this one times 2, or this one divided by a half. So let's go ahead and write those similarity statements. A, B, C, D, E is similar to, now we have to get this in the correct order. Notice the order we named the first one. A would be corresponding to S, R, V, U, T. All right, and then I already alluded to the scale factor. If you're going from A, B, C, D, E to S, R, V, U, T, how do I get from here to there? The scale factor is 1/2. That's dividing by 2. If I'm going from S, R, V, U, T 2, A, B, C, D, E. It's the reciprocal. The scale factor is 2. So there you go. All right, a couple more problems here. It says these two figures are similar. We're asked to find the value of x and y. So just set up some proportions with corresponding sides. So let's see. I would have x corresponds to 7.5 is equal to top and top. Y corresponds to 5 is equal to 6 corresponds to 9. All right. So to find x, the first thing we do is we would ignore that middle one because we don't want to use two fractions with variables, and we would cross multiply those outer two. So imagine cross multiplying those. The x and the 9 are going to get multiplied together, and the 6 and the 7.5. 6 times 7.5 is 45. So if 9x equals 45, x, of course, is 5. And then to find the y, we could either plug in 5 for x, or we can just cover it up and use the one that has the two numbers in, and imagine cross-multiplying that. 9y equals 30. So then we take 30, and we divide it by 9, and it comes out to be, well, it doesn't really go into it evenly. So we probably just want to reduce that fraction to 10 thirds, because 3.3 repeating is pretty gross. So let's just leave it at like that, 10 thirds. There you go. Simple. And then here you go, some application problems. Where is this useful? Similarity. Here is an example. Somebody's making a poster. The design on the computer is 6 inches by 10 inches. The space allowed is 4 feet by 8 feet. So we want to know what are the dimensions that will fit the space. So we can't have it too big to where it's like either too wide or too long. So we need to fill as much as we can that will not overlap or like go over the boundaries of this wall or whatever it is we're putting the poster on. So we got to blow this thing up exactly the way we want. Now notice, the design is in inches, and the space we're talking about is in feet. So if this were me, I would probably convert that to inches. So that's a space of 48 inches by 96 inches. Okay, so our design is 6 to 10. So there are two ways we can do this. We can either make the 10 go up to exactly 96, or we can make the 6 go up to 48. So we got to see which one would fill better. So let's look at the first scenario. If I go from 10 to 96, I need to figure out what can I multiply 10 by to get to 96. Well, to figure that out, you just take the one you're going to and divide it by the one it started as. 96 divided by 10 is 9.6. So that's my scale factor, 9.6. I'll take that 6 and I'll multiply it by my scale factor. If you type that into your calculators, 6 times 9.6 comes out to be what does that come out to be? I don't know. 6 times 9.6 is what? 57.6. Now let's look at our dimensions. It's only 48 inches. That's too big. It's not going to fit. So that one's not going to work. Let's instead look at our other scenario. To get from 6 to 48, let's try this scale factor. 48 divided by 6. 6 times 8 is 48. So our scale factor is 8. If I take that and I apply it to my other number, 10, 8 times 10 is 80. That is going to fit because it's 96 inches wide. So what's the dimensions of the largest poster that's going to fit in the space best? it's going to be 48 by 80 inches, by the way. So there you go. And then down here, why don't you try that one? We got the same poster that we're talking about. It starts as a 6 by 10. We want to know how would it fit best in the 36 by 48 area. Try that one. Pause the video. See if you can figure it out. All right, let's see. Let's consider our first scenario. To get from 10 to 48, that scale factor would be 48 divided by 10. That's 4.8. If we take the other number 6 and multiply it by the scale factor, 6 times 4.8 comes out to be 28.8. That will fit in our 36-inch area. So that one fits well. We'll see if the other way would fit. What if we went from 6 to 36? Well, that's a scale factor of 6, right? If I take 10 and multiply it by 6, that's 60. That will not fit. So this is the one I want, the 28.8. And that was using 48, right? So it would be a 28.8 by 48 inch dimension. Hope that makes sense. Those ones are kind of weird. If you are struggling, check out some extra examples on my math lab and look to see what the author has posted in her videos, or ask a friend. You'll do fine. Good luck. I'll see you tomorrow. I'll be back. See you then.